Hey, this is the answer key for review 2 for chapter 6. First thing, I want to make sure that I point out, do you see that this one is missing the C problems? Make sure you look at review 1. Review 1 has all of the types. This one is missing one of those solve for C's. So, the first kind of problem, we are going to verify that the function is a solution. There is one of these on your quiz, quest, test, whatever you want to call it. So remember, step 1, I'm verifying that this is a solution. So the first thing I'm going to do is I'm going to take its derivative. And when I take its derivative, the 4 comes down. The derivative of e to the negative x is e to the negative x. And then that would also be times the derivative of the exponent, negative 1. So my derivative is actually negative 4e to the negative x. Okay, so we've got that done. Switching colors. Second part, you are going to make your giant T. And on one side of the T is y double prime. Subtract y equals 0. And now that I looked at this and it says y double prime, and this is only y, oh, we got to go back again. And now we've got to find our second derivative. So we're going to take the derivative again. So y double prime is going to be negative 4 comes down. Derivative of e to the negative x is e to the negative x times negative 1. So y double prime is positive 4e to the negative x. Okay, so now back into my t, that y double prime, wherever I see that, I am going to put 4e to the negative x there. And I am going to subtract y, which happens to be 4e to the negative x. And look at that. 0 equals 0. Guess what? I win! I would hate to disappoint you guys and you not hear me say that. So, did my verifying. So now let's take a look at the next one. This next one has a C in it, but there are no points given. So since there are no points, I can't solve for C. So it's solve for C if possible. So first thing I'm going to do, my derivative y prime equals. The C is some kind of a number, so it just stays there. And now power that down. That's going to be times 3x squared. So in other words, I could rewrite this as y prime is going to be 3cx squared. Okay, so now that I have my derivative, I'm going to make my t, and on this side is x, y prime minus 3y, and on the other side is 0. So we're going to start off that x is going to stay there. My y prime is going to be 3cx squared. And I'm going to subtract 3. And my y value is cx cubed. Okay, so multiply this out. This becomes 3cx cubed. Subtract 3cx cubed. And guess what? 0 equals 0. I win! And if you read at the top, there is one of these on your quiz. So, let's continue on. The next section has some solve the differential equations. Notice that there are 4 of these on your quiz. So I could give you any amount that I want. For this first one, there's a dx that's got to be moved over, and I'm left with dy equals the negative 2x to the 4th plus 5x, and that is all times that dx. If you don't put the parenthesis there, I'm okay with that. So remember, you do have to tell me that you are integrating these things because that's the process we're doing. So this becomes y equals, the negative 2 comes out in front, x to the 5th now. So I've got to divide that by 5 plus 5x squared. Got to divide that by 2 and then plus c. And looking to see if I could simplify anything else. I can't. So that's my answer. Ta-da! And we're done. The one thing, no, I guess that's it. The one thing I would say is just make sure the negative sign is by the 2 out in front or down by the 5. I would take it either way. So moving on then to the next problem. I would never leave a root in here, so I always think of it as dy over dx equals negative 5, and this y value would be raised to the 1/3 power. So the way that I'm planning on doing it, I have the dy left on the left side, and I would be dividing by y to the 1/3 power. And then on the right side, I would leave the negative 5 and the dx. And then I need to remember that I am integrating these things. Okay, so now this is a fraction. So you're asking yourself, can you split it? If you can't split it, then you're going to ask if you can bring your bottom to the top. And in this case, you can bring your bottom to the top. So this is the integral of y to the negative 1/3 dy equals the integral of negative 5 dx. I can now power these up. When I add 1 to that, it becomes to the positive 2/3 power, which means I'm multiplying by the 3/2. That's going to equal my negative 5, my x's being squared now, dividing by 2, and adding on c. So I've got to get this y by itself. So the first thing I'm going to do is multiply by 2/3 on each side to get rid of that y hooked on there. And when I do that, let's come back up here by the top, I'm left with y to the 2/3 power is going to equal, oh look, this 2 and this 2 cancel each other out. Negative 5x squared over 3 plus c. And again, that c value, it gets multiplied by the 2/3, but I'm not going to worry about that. And from there, I now have to, I'm just looking at my notes, and I think I did something goofy here. No, I didn't. I did do something goofy here. Okay. We need to go back. I need to go back a long way because I goofed. So, no one raised their hand to tell me that I goofed here. There's no x already on that. So this is just negative 5x plus c. There's no 2 there. So back to what I was doing. Yes, I would have to multiply each side by 2/3. And then I would bring that up here like I did before. And I'd be left with y to the 2/3 power, but this time it's going to equal negative 10x over 3 plus c. Now, we need to get rid of this 2/3 power. So, to get rid of that 2/3 power, I could raise this side to the 3/2 power. That means this is also going to be raised to the 3/2 power. Technically, c would be also, but what's going to happen to that c? It's just going to stay c. So I end up with y equaling negative 10x over 3 raised to the 3/2 power, and you don't have to rewrite it in radical form, plus c. That would be my final answer. Sorry for that boo-boo, guys. I wasn't paying attention. Okay, so now down to this next problem. So when I look at this next problem, x's are here in the exponent, x's are here in the exponent, x is here, the only y is there. So first thing that I'm going to do is get my y by itself. So when I do that, I end up with dy equaling my 3e to the 4x power divided by 1 minus e to the 4x, and then I'm going to have my dx behind it. And again, just like I've said before, you need to tell me what you've got to do. You've got to integrate this. So this becomes y equals, ooh, and this is a fraction. So I should have done a little work before I got excited and wrote that y equals. So I'm going to just slow down a little bit, trying to get this done fast. And I need to recognize that I have a fraction here. So I'm asking myself, can I split it? My answer is no. Can I bring the bottom to the top? Not without a -1. So then my next choice is making a du over u. So my u value is going to be 1 minus e to the 4x power, which means my du is going to be a negative e to the 4x times 4 dx. Okay, so now we need to look at what we have here. I have on the top the dx, got it. I have an e to the 4x and an e to the 4x. I don't have this negative sign, so a negative sign here and a negative sign on the outside. I don't have a 4, so a 4 out here and a 1/4 out here. So now I got to rewrite this. So what do I have left? I have the integral of dy equals the negative and a 1/4, and the 3 here I'm also going to bring out. So that 1 I'm actually going to make into a 3 now so you can see where it went. The integral, and then I have a du over u left. So now y would equal negative 3/4 natural log of my u value, which is 1 minus e raised to the 4x power. And don't forget, plus c. The y is by itself. So guess what? I'm done. Okay, so let's take a look at this last one. This has a y hooked onto it. This has the x. And you don't add and subtract these y's. So I have got to think of this whole thing as being times 1. So I can rewrite this as dy being divided by 3 minus 2y, and it's going to equal dx. So I am going to integrate this. And as I integrate this, I'm looking, oh, this is a fraction. I ask myself the questions. Can I split it? My answer is no. Can I bring the bottom to the top without any -1s? My answer is no. So what do I have to do? My u value is going to be 3 minus 2y. My du value would be a -2 dy. And I'm looking at all of my pieces here. I have my dy, got it. I don't have my -2, so I'm adding in my -2, so there's a -1/2 on the outside. So what does that give me then? I have a -1/2. The integral of du over u would equal the integral of dx. I can power this up now. Negative 1/2 the natural log of my 3 minus 2y equals an x plus a c. Okay, we've got to start to get this natural log by itself. So I am going to multiply this side by 2 and multiply this side by 2. And now I'm going to zoom up here where I have a little more space. And I'm going to have the natural log of 3 minus 2y would equal 2x, negative 2x, I apologize, negative 2x plus that c value. Okay, remember there's an e here, so I can rewrite this as e to the negative 2x plus c equals the 3 minus 2y. Remember, the c automatically comes down in front, so ce to the negative 2x subtract 3 would equal negative 2y. We did a couple of things there. So finally, my answer is ce to the negative 2x divided by negative 2 plus a 3 over 2 equals y, or I'm going to switch colors just so you can see it here. The 2 and the c could absorb each other. You could just also write it as ce to the negative 2x plus 3/2 equals y. Ooh, that looks really bad. Sorry about that. I would accept either or for a solution here. Okay, getting if you understand how the c's work. I believe there is one more solve for the differential equation here. This one again is a little bit harder because it doesn't have the dy dx in it, and it has a lot of variables in it. So we're just going to try to break this apart. So I have x dy dx. I'm going to just move it over, equals x plus 1 times y. That made it pretty easy. I got rid of that plus or that minus sign, got my dy dx in there. I can see I'm going to divide by y. I'm going to divide by x, multiply by that, and I end up with dy over y equals x plus 1 over x dx. Okay, so we've divided it. We are going to integrate it. Left side's easy. It's a dy over y. That's a du over u. We can work that one out. This one here is a fraction. So with that fraction, the first thing I ask myself is, can I split it? And my answer is yes, I can split this. So notice I tried to give you a little variety here of things. So I have the integral of dy over y is going to equal the integral x divided by x is 1 dx, added on to the integral of 1 over x is x to the negative 1 dx. Okay, so now power them up. The natural log of y is going to equal x plus, oh, that x to the negative 1. Does that actually work? Oh, I thought I was being so smart. Darn it. It doesn't work. I can't have negative 1 there. That's the rule. So this is 1. Ooh, that's icky. This is 1 over x. Oh, 1 over x. This is a natural log of x plus c. Now, if you're not getting that natural log of x, you could be doing u sub. You could let your u equal x. So your du would equal dx, and you could rewrite that as that natural log. Sometimes people just recognize that that is the natural log, which I just did. Okay, so this turns out to be a little bit on the messier side. I need to get this y by itself. I could care less about the x's. Get this y. So this is going to be rewritten y equals e, and it's being raised to the x plus natural log of x plus c power. That whole thing is its exponent. Well, what do we remember about the c? It's going to come down in front. So my final answer, or I shouldn't say my final answer, I am going to get my y equal CE raised to the x plus natural log of x power. And I'm going to leave it like that. That's fine. We're done. Because there's no way to solve for C because they didn't give me any numbers. That's it. Okay, on to the last two word problems. So for this last problem, remember there is one of each of these on the test, and this one has three parts. So we're going to start off with the setup. The setup of this radioactive radium has a half-life of approximately 1599 years. So this first sentence is going to help me solve for my K value. That is what I can remember. Now, something that I assume you guys remember, but I'm not sure. If you remember the equation y equals CE to the KT power, that's the equation that we have to use. C is your beginning, Y is your ending, and then K is your constant, T is your time. So to solve for K, I have something called a half-life. That means half of the material is left when I begin with 1, starting 1, ending 1/2. E being raised to the K, and that would be 1599 for time. Oh, well, we've done these before. We're going to introduce, don't know what that's doing. We are going to introduce a natural log on each side, and that's going to give me the natural log of 1/2 equals K times the 1599, all times the natural log of E, which is 1. So my K value I just found out is the natural log of 1/2 divided by 1599, which means that I now have an equation of y equals CE to the natural log of 1/2 divided by 1599 times T. Okay, so I solved for K. That's what the red box did. So now going on to the blue. The initial quantity is 28 grams. That tells you C equals 28. I didn't have to solve for it in this one. On the review 1, you had to solve for C. So guess what? I now know my equation is y equals 28 e to the natural log of 1/2 divided by 1599 times t. Okay, switching colors for the last time. How much remains after 1150 years? So to find my final question, y is going to equal 28e raised to the natural log of 1/2 divided by 1599. And now that's going to be times 1150. The t was replaced. This is a calculator problem. You need to put this onto your calculator. And when you do that, you should end up with y equaling 17.008 grams. Okay, that's your final answer. There's going to be something with that initial growth and decay. So last one that we have. Now remember, we just had the equation y equals CE to the KT power. And this is A equals PE to the RT power. Oh, they're the same thing. Ending, beginning, rate, time. So, what do I need to know? Find the time. So I'm looking for T is my question mark. For $3,500, that's my principal. To double, so my ending would be 7,000. If it's invested at a rate, and remember that's 0.025 when I change it into decimal form. So let's not do Y. Let's do A equals PE to the RT power. My A value, my ending value is 7,000. My P value is 3,500. E raised to the 0.025 is the rate, and T is what I'm solving for. So now you just need to remember how to deal with your exponential equation. First thing you got to do is get rid of this 3,500. So 7,000 divided by 3,500 is going to equal E raised to the 0.025t. The t is stuck in the exponent, so we're going to introduce natural log on each side. And guys, this turns out to be the natural log of 2 equals 0.025t natural log of E, which is 1. My time is going to be the natural log of 2 divided by 0.025. And that time turns out to be on my calculator 27.125 years. Study for your test. Make sure you've looked these things over. I will be collecting the homework. I'm not going to collect the reviews. The reviews are something that you need to do for yourself. So, good luck. See you Thursday.